Oh, that, yeah, I think in a lot of practices across the globe. Now, your work on the disruptor P.A.D plus, is that how I pronounce it? Trial explored
Yeah,
innovative approaches. Yes.
yeah, just the P.A.D. trials, yes.
Yeah. What aspects of that study in particular, really stand out to you in influencing PAD care?
Yeah, so there were three trials, and the first one, well, the first two were really combined, Disrupt PAD 1 and 2. These were the first trials ever done with ShockWave, with the commercial device. I can talk a little bit more about my very first in human experience with ShockWave, but this was because I did the very first cases, but this was the clinical trial that looked to validate, did this thing even work? And so patients were randomized to either they weren't randomized in these trials. We just built up some experience with Shockwave. And wow, we found it had an incredible effect in femoropopliteal calcified disease.
Yeah.
Shockwave 1 and 2 really didn't show the durability that we wanted to see. So the Shockwave Disrupt PAD 3 trial, that was the pivotal trial where patients were randomized to either plain balloon or Shockwave and then got a drug-coated balloon. And that had a highly positive result, which really meant that Shockwave became available to clinicians all around the world, including particularly in the US, who have been strong users of this technology. So that was a very impressive series of trials to be involved in.
I think that Shockwave has really been incredible in this world where there's so much points of contention with the atherectomy devices for vessel preparation, that there is this alternative. And even those who have been against atherectomy, here in the US especially, they're still adopting this lithotripsy. And if you can explain, just for patients who are watching in right now, the Shockwave technology and how it works and why it is impactful, especially when paired, and it's supposed to be paired, right, with drug-eluting balloons.
Yeah, great point on that, Kim. Yeah, absolutely, because it does produce restenosis, so that you need to have an anti-restenotic therapy. But to answer your question, it's basically an angioplasty based treatment, so something we're very comfortable with. But inside the angioplasty balloon are multiple lithotripsy sources. Now, these lithotripsy sources are high energy ultrasound. What they basically do is they produce make gas bubbles expand and collapse within the angioplasty balloon. And that phenomenon produces sonic pressure waves or ultrasound pressure waves that transmit through the vessel wall. Turns out they're very hard on calcium, but they don't disturb normal tissues. And what they then produce is microfragmentation of the very calcified artery and return it to a much more normal state, so that you can then dilate it as you would a normal artery at low pressures, and you don't have all the complications of dealing with calcium. That was the theory, of course, but and I was very lucky to get involved right at the start as we proved its effectiveness. So, it really, as you say, I don't think it's a competitive technology for atherectomy. I think there are cases where we sometimes use both technologies, but it certainly adds to the armamentarium, and it seems to be very safe. So those issues we're worried about with atherectomy, distal embolization in particular, Shockwave just hasn't reported that kind of experience, and we certainly haven't seen that.
And it's now used in the heart. So I can
Yeah,
only imagine that it's the FDA considers it a safe and effective device.
yeah, very safe technology. Yeah.